Here we will start with the new topic, and the name of the topic is derivatives of the composite functions. Okay, so I will write here derivatives of composite functions. So first of all, we have to learn what is meant by the composite function. So important term here is the composite function. So we know the function is like that: the sine, cos, tan, square root, these are called as the functions. Suppose I take one example, that is, suppose we want to find out the derivative of this particular function, square root of something, and if I have the quadratic equation x square plus 4x and minus 7, if this is the equation, and if I want to find out the derivative of this particular composite function, so how to solve this particular problem? So basically we have to first of all concentrate on this particular problem, and we have to see that this function is called as a composite function. It is because this is dependent on the x square plus 4x minus 7, means it is a one function, and square root itself is another function. So the net output, if I consider this as a y, then y is equal to square root of x square plus 4x minus 7. So net value of the y depends on the value of the x as well as its square root. Okay, so x square plus 4x minus 7, this expression is a one function. Okay, and the square root of that particular quadratic equation is the second function. Okay, so function of function. So how to solve this particular problem? So we have to first of all arrange this particular y in the form of this quadratic equation x square plus 4x minus 7 as it is. It is raised to 1 by 2. Okay, either write down it as square root or raised to 1 by 2, one and the same. So it looks like x raised to n formula. So if I take the derivative of this y with respect to x, then powers comes in multiplication and power is reduced by 1. So entire expression, its power is reduced by 1, means 1 by 2 minus 1, means we are 1 by 2 minus 1, it is a minus 1 by 2. So if it's in multiplication, power reduced by 1 into derivative of this quadratic equation x square plus 4x minus 7. Okay, so dy by dx is equal to it is 1 upon 2 square root of x square plus 4x minus 7, and the derivative of this quadratic equation, powers comes in multiplication, power is reduced by 1, plus 4x derivative is 4 constant as is it, derivative of x with respect to x is 1, and derivative of the constant is always the 0. Okay, so if you solve this particular, then you may come to the dy by dx equal to 1 upon 2 square root of x square plus 4x minus 7 into 2x plus 4. So we can simplify this. 2 can be made common, so it is x plus 2, and it is 2 square root of x square plus 4x minus 7. So this 2 and 2 will get cancelled, and you will get the output x plus 2 divided by square root of x square plus 4x minus 7. So ultimately we can see that its derivative of x square plus 4x minus 7, its square root is equal to this. Okay, so here I can write, so ultimately finally I can write the derivative of square root of x square plus 4x minus 7 with respect to x is equal to x plus 2 divided by x square plus 4x minus 7, or it can be also written as a dy by dx. So this is our final output. Let's consider this particular function. So in this particular function there are the two functions. Okay, So square root is a function, again the tan is a function, and again the square root of x is a function. So there are three functions in dot, so it is called as a composite function. Okay, so this is called as a composite function. So how to find out the derivative of this particular composite function? So we have to make, first of all, say y is equal to square root of tan of square root of x. Okay, then we have to make the derivative of this y. So dy by dx is equal to, it is a square root, so its value we can write as, or this tan of square root of x raised to 1 by 2, this can be written like this. Okay, so power will comes in multiplication and its power will be reduced by 1. So I can represent it like 1 upon, yes, because it is a composite function, we have to take the derivative of tan of square root of x again. So it will become 1 upon 2 square root of tan of square root of x into, now the derivative of the tan x is sec square x. So I will write sec square x, instead of x there is a square root of x, so I will keep it as it is. Again I have to keep the derivative of square root of x as it is. So this will become, now this is in a numerator, so sec square of x divided by 2 square root of tan of square root of x, and it will become, the derivative of square root of x is 1 upon 2 square root of x, and again the derivative of x is 1. So this will be our final output. So ultimately I can state that the dy by dx in this particular case, so dy by dx, which is equal to derivative of this particular function with respect to x, is equal to sec square of square root of x into 2 into 2 is a 4, and again the square root of tan of square root of x into square root of x. So this is our final output. Okay, now it is a function. Now this is also the composite function, first of all, because it is dependent on cot is a first function, log is a second function, x cube is a third function. So it is a function of function like that. So how to solve this particular problem? So we have to first of all consider this as a y is equal to cot cube of log of x cube, then dy by dx, derivative of y with respect to it is a cot cube of log of x. So we have to first of all know what is the derivative of this particular cot. Okay, so basically before the cot there is a cube function. Okay, so there are 4 functions available. One is a cube function, this, okay, first one is a cube function, then the cot function is available second, then the log, and then x cube. Okay, so it is the first function, it is the second, it is the third, and it is the fourth. So first of all we have to solve the first function, that is the power comes in multiplication and power will be reduced by 1. Okay, so like this, and then the derivative of the second function means cot function, log of x cube as it is. Then it will become 3 cot square log of x cube, and now the derivative of the cot, tan is sec square x, cot is minus cosec square x, so its derivative minus cosec square x, instead of x there is a log of x cube, and again the derivative of log of x cube. So I will take the minus sign common, 3 as it is, cot square of log of x cube okay. So log of x cube, then cosec square of log of x cube as it is, and then the derivative of the log, that is 1 upon x cube, and then the derivative of again the x cube. So I will make it again. I have to minus 3 cot square of log of x cube, right, then cosec square of log of x cube. This is 1 upon x cube, and the derivative of x cube is 3. Powers comes in multiplication, power will be reduced by 1. So this 3 and 3, this will become minus 9 cot square of log of x cube, and it is a cosec square of log of x cube, and it will become, I think this square and this square will cut, only x will become. So this is entire divided by x. So ultimately dy by dx is this. So we can state that the derivative of this particular derivative of this cot cube log of x cube is this particular. Now we have to find out the derivative of this particular function. So I will first of all make it equal to the y. So y is equal to log of cos x raised to 5. Now how many functions are there? So log is the first function, then the cos is the second function, x cube is the third function. So 3 functions are there. So it is the example of the composite function. So dy by dx is equal to, first of all take the derivative of this particular. So d dx of log of cos of x raised to 5, then derivative of this log is 1 upon cos of x raised to 5. Okay, so derivative of this log function is over, and then we have to find out the derivative of the second function, that is the cos function. Okay, then it is equal to 1 upon cos of x raised to 5. Derivative of the cos is a sine, but it is a minus 1. Okay, the derivative of the cos is a sine. Yes, derivative of the cos is a sine x raised to 5, and again I have to find out the derivative of x raised to 5. So it will become 1 upon cos x raised to 5, and yes, minus sine of x raised to 5, and the derivative of x raised to 5 is powers comes in multiplication, power will be reduced by 1. So this minus sign as it is, sine x raised to 5 upon cos x raised to 5, so it will become tan x raised to 5 will be as it is, and x raised to 4 will be as it is. So in short, what? So dy by dx will be equal to minus 5 x raised to 4 into tan of x raised to 5. So this is our final output.